Okay, we're going to try to find a vector in this space that maps onto a vector in this space that's parallel to it. So the question we have is, we're going to assume there exists a vector v1, v2 such that our matrix for this transformation multiplied by v1, v2 is parallel to the vector v1, v2. Okay? Now, it doesn't, just because we assume that it's so doesn't mean that it is so. If we arrive at a contradiction, then we're going to find that it isn't so. We're going to conclude that it isn't so. And the answer to our question, as I suspect it will be, is going to be no. Just looking at the way these vectors rotate, I think the minimum rotation is going to appear somewhere between the blue and the orange vector. Okay, and that rotation is not going to be zero. You're going to still have a positive rotation. I think so, looking at that picture. But I don't know, so I'm testing it. If I'm right, then this is going to lead us to a contradiction. If I'm wrong, then we'll find the vector we're looking for. So the question is this parallel to this? Well, that means the same thing as saying that this vector is a constant multiple of this. Okay, because one vector is parallel to another if each is a constant multiple of the other. Okay, well, if that's the case, then we would have this equation, that this is equal to some multiple of this, and the constant that we're going to multiply by this, that this is going to need to be multiplied by, is going to be called lambda. Okay, now this should remind you of the eigenvalue problem. That's exactly what it is, but we're looking at the geometric meaning then of eigenvalues and eigenvectors. Okay, so we have this equation. If we can solve this equation for lambda, and if we get a real number for lambda, then our answer to the question is going to be yes, and we're going to be able to find the vector that we're looking for. Okay, well, this equation translates into two linear equations, and we can write those linear equations like this. Okay, and these linear equations can be solved by substitution or by matrix reduction. So these equations here, question is there a lambda that makes this true? Okay, does there exist such a lambda? And if so, then what does that tell us about the coordinates v1 and v2? So we're going to look at the solution to this system of equations in the next clip.